Today, it is my pleasure to introduce my research content. Today, I will introduce the topic is research on energy equipment and system based on sound and vibration signal. I will introduce from the following aspects. First, education and working experiences, research interest, project experiences, publication and proceeding, patent and soft copyright. This is my education and working experience. I got my PhD done from the Zhejiang University, and after the graduation, I worked at the Shandong Jianzhu University, the Department of the Thermal Engineering. My research interests include fluid machinery design and optimization, dynamic control technology of building environmental theater, vibration and noise control, and this is my research content. First, I will introduce the first aspect. Research on electronic, magnetic, and vibration characteristics of dynamic eccentric PMSM based on signal demodulation. Manufacturing error and air gap deformation are the most common cause of unbalanced magnetic profiles, which influence the stable operation of rotating machinery. In this study, the characteristic of magnetic field and vibration in the permanent magnet synchronous motor were investigated through the electromagnetic field element situation and laboratory measurements. The result of vibration acceleration of electronic magnetic features measured in the simulation and experiment were discussed by signal demodulation method. Based on the virtual working principle, the distribution of unbalanced magnetic pole under different eccentric conditions were obtained. Focus on the existence of the couple relationship between electromagnetic field and mechanical frame. The signal demolition method based on the principle and component analysis were applied for the attracting modulation features in experimental frame. It was found that the amplitude modulation of magnetic fluids and the intensity on the vibration acceleration signal enhanced. Nevertheless, the distribution of time domain signal measured in experimental was different from the under weakened coupled condition, which could be caused by the frame aberration. The aim of this study is to reveal the modulation features of the motor, which could provide the engineering reference for the further diagnosis of rotating machinery system. The second content is gravitation characteristics analysis of a novel rotor ratio grooved hydrodynamic gravitation reactor. Hydrodynamic gravitation was widely used in sterilization, emulsion, preparation, and other industrial fields. Cavitation intensity is the key performance index of a hydrodynamic cavitation reactor. In this study, a no-rotary sugar-roll hydrodynamic cavitation reactor was proposed with good cavitation intensity and energy utilization. The cavitation performance of an RRG hydrodynamic cavitation reactor was analyzed by using the computational fluid dynamic method. The cavitation intensity and the cavitation energy efficiency were used as evaluation indicators for RRG hydrodynamic cavitation reactor with a different internal structure. The amount of generated cavitation for various shapes of the CGU, interaction distance, and the rotor speed were analyzed. The evolution cycle of ion cavitation morphology is predicted in the CCG and RRG hydrodynamic cavitation reactor. The main cavitation regions of CGU was the outflow and inflow separation zone. The cavitation performance of the rectangular shaped CGU was better than the cylindrical shaped CGU. In addition, the cavitation performance could be improved more efficiently by increasing the rotor speed and decrease the interaction distance. The research result could provide theoretical support for the research of the cavitation mechanisms of cavitation equipment. For example, the third is study, experiments, and numerical investigation on the disinfection characteristic of a novel rotary sugar-roll hydrodynamic cavitation reactor. Hydrodynamic cavitation was considered as a new efficient and groundwater treatment technology, which doesn't produce any disinfection byproduct. In the present study, the disinfection characteristic of a novel rotary sugar-roll hydrodynamic cavitation reactor were evaluated. The effect is of various rotor speed, fluid rate, and initial bacterial concentration on the removal of the recapture coil were analyzed on the basis of experimental research and numerical simulation. The portable mechanism of hydrodynamic cavitation disinfection were planned 93.3 disinfection rate of coil can be obtained at 3,100 RPM and 2 in the 20 minutes for 12 water of simulated effluent. With the increase of the flow rate, the disinfection effect of the rotor was improved based on the cavitation effect and the exposure time bacteria in the bottle calibrates area. The disinfection of alcohols based on the mirror jet, shock wave, and shear stress generated by the hydrodynamic cavitation The funding of the present study can provide support for the application development of hydrodynamic causation, disinfection, and the theoretical development of the ratio hydrodynamic causation reactor. The last fluid introduced the noise mechanism and optimization of designed electronic evaporation valves. Electronic evaporation valves is one of the sources of noise in the operation of the air conditioner. In order to suppress noise, a strut with switchgear run downstream is proposed in this study. For the noise problem caused by the electronic evaporation valves, the word and the different pressure different numerically and the list. The reliability of the simulation is verified by experiment, and the noise of the prototype and the optimization model are compared and analyzed. The result showed the two-phase flow noise increased with increasing of the pressure difference between the inlet and outlet of the electronic evaporation valve. When the pressure difference increased from the 1 mpm to 2.5 mpm, the noise increased from the 90.84 to 102.3. The upstream flow of the wave is stable and there is no causation noise. Therefore, the noise upstream of the valve can be ignored, where the noise is mainly generated in the downstream area of the valve, and the noise is similarly distributed. The distribution is characterized by small noise in the center and near the wall, and there is a minimum noise in the middle. Compared with the original model, in the optimization model, the gas volume friction in the flow field increased and the maximum noise decreased by 13 dB. Many research projects implement this as follows. For example, study on the fluid noise mechanism of the centrifugal pump and a steady condition based on the modulation characteristic. And the second is the study on the mechanism and the intelligent identification method of fluid introduce the vibration and the noise of centrifugal pump. And then from the research content, we have published many research papers, for example, the pump application and proceedings. And these are also the publication and the proceedings, and so on. Besides, we also get some patent and soft copyright, for example, a method for the calculating and analyzing a balanced electronic magnetic force on the motor, and so on. Those are the main patent and soft copyright. And that's all. Thank you for your kind attention.